Upon careful consideration of both the alt-azimuth and equatorial mount types, we chose to go with the latter. The equatorial mount allows for a simple initial calibration of the system, which will remain accurate for long periods of time.
Using pre-existing models of a telescope and solar panel, we were able to construct the following representative model of our system. On the left, you will notice that the base mount is an equatorial mount whose polar axis is orientated towards the North Star. A counterweight is attached opposite of the solar panel to reduce torque on the motor. And on the right, you'll see a better view of the solar panel attached. We'll now remove the solar panel from the image and take a closer look at how to calibrate the mount.
The polar axis of the mount can be rotated from 0 to 90 elevation degrees to be directed towards the North Star. We recommend an annual calibration to ensure continued accuracy of the system. Once calibrated, the solar panel can be adjusted to face perpendicular to the sun's rays. Then, using the sun's elevation angle data that is local to the mount site, the equatorial mount can rotate the solar panel with simple rotary motion about the polar axis as is seen here.
In order to achieve the back and forth motion required to keep the solar panel rotating forward and back, the quick return linkage system shown here was devised. The crank is powered by a rotary motor that rotates at a constant speed of 6.96 times 10 to the negative fourth RPMs, which equates to one full rotation per every 23.934 hour day. The output rocker in this mechanism completes its forward motion in the time that the sun remains in the sky, 14 hours, and returns back to its initial position during the night, arriving just in time for the next sunrise. As the crank seen on the left rotates through its complete 360-degree rotation, the rocker moves from an initial position of 0.43 degrees above the east axis to 2.98 degrees above the west axis. This comes to a total of 176.59 degrees of rotation from sunrise to sunset. The crank encounters two toggle positions along its motion path when the rocker changes direction. The first is at 46.9 degrees and the other at 266.3 degrees from the east axis. With the linkage motion applied to the model seen earlier, the following is an animation of the completed system, where 1 second is equal to 1 hour in the day.